The concept of anti-lock braking is nothing new, but it took decades for the technology to evolve to the point where it became a standard safety system on passenger vehicles. The roots of the anti-lock braking system, or ABS, can be traced as far back as the early 20th century, although it was applied to trains and aircraft at first. Momentum really picked up in the 1970s when Chrysler and Bendix introduced the SureBrake four-wheel electronically controlled ABS as an option for the 1971 Imperial, and Mercedes-Benz introduced what it called the second generation ABS in August 1978. Modern four-wheel ABS was first offered as standard equipment in the mid-1980s on some higher-end models, and by the mid-1990s, ABS was on the majority of new passenger vehicles. Since the 2012 model year in the United States, all new passenger vehicles have been required to come equipped with electronic stability control. Since electronic stability control incorporates ABS technology, it's safe to say that pretty much every new vehicle on the road today has anti-lock brakes. Four-wheel ABS addresses a fundamental safety problem: the fact that the average driver isn't able to modulate pressure on the brake pedal in emergency situations without locking the wheels or lengthening the stopping distance. The ABS relies on ABS sensors mounted at each wheel hub to monitor wheel speed and send that information to the ABS computer, although some rear-wheel drive applications have the sensor mounted in the rear differential. The ABS computer uses this information to prevent the brakes from locking during a stop, pumping the brakes if needed. The performance of ABS sensors has always affected how long it takes a vehicle to stop, but in recent years, ABS sensors have taken on additional responsibilities. Safety systems such as electronic stability control, hill hold assist, and automated braking depend on ABS sensors to function properly. More and more ABS sensors now have multi-directional capabilities, which means they not only monitor the speed of the wheel rotation, but also the direction the wheel is rotating. This standard ALS684 ABS sensor uses multiple microsensors to produce the unique forward and reverse signals that modern vehicles require to keep the electronic safety systems working correctly. Standard points out that there are other ABS sensors in the market that cannot determine which direction the wheels are rotating. That means they can't provide enough information to the ECU, and that can disrupt those critical electronic safety systems that we've been talking about. When you're recommending a replacement ABS sensor, be sure to recommend a sensor that's engineered to match the OE performance in all conditions and situations. Standard ABS sensors are designed to perform correctly on the vehicle, keeping your customers safe. Features such as superior magnetic circuit materials are engineered into the sensors, delivering the right voltage output in all situations. The sensors are durable thanks to a housing made from glass-reinforced synthetic resin and a protective wire harness sleeve that prevents wires from chafing and creating short circuits. And they're easy to install thanks to grommets and wire clips on the harness for proper mounting and routing within the vehicle chassis, and OE connectors and terminals that ensure an accurate, watertight connection to the engine wiring harness. When you're recommending a safety-critical replacement component such as ABS sensors, don't take any chances. Only recommend a part that can match the performance of the original in all situations. Thanks for watching.